Coming through? Okay, good. Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Lip-Bu Tan, the CEO of Cadence. Lip-Bu, welcome back, and thank you all for coming this morning. Lip-Bu, you cover a broad swath of the world as well as many markets. What do you see as the most important emerging markets these days, and why?
Yeah, I think we are moving into this, I call it the data-driven economy. And so it's all everything about data. So from a lot of devices, sensor to collect data. And then the other part is, how to depend on what applications. And it will move into the intelligent edge. And so like industrial 4.0. And then when you collect the data, you want to process in a very low power. And so they can drive productivity and efficiency. And then the other part is to really move up into the scale to the cloud. And there's a hyperscale guy pouring 80 billion capex this year to build out the infrastructure that you really don't need to build the infrastructure for anything that you want to drive the applications. So in some ways, very similar to our, in fact, last week, I went to see Morris. And when he retired, and I said, well, the biggest contribution you make is all the fabless guys don't have to build a fab. And so much more cost effective and more efficient. So again, thanks to Amazon, Microsoft, Google, Alibaba, they're really building up infrastructure massively scalable. And so you can really process the data in a very fast way. And so I think over time, we're going to see massive scaling of the cloud. And that changed a lot of infrastructure requirement in terms of storage network. And then the other part is some of this intelligent edge. And then you're going to see a lot of this, I call it the vertical cloud, from mobile cloud to auto cloud and some of the vertical cloud. And so I think, the world will be very different. And all this is going to changing a lot of design. So we at Cadence, we see tremendous design activity going on. Especially in AI, machine learning, automotive, and biosensor related area. So that thing, I think is just great for the industry. Last year, industry grew at 20%, past 400 billion. And stay tuned, I think in the next 5 years, I think the industry will grow more than double last 5 years. So I'm excited.
Do you think the cloud has hit a limit? Is it still just in the beginning of its growth phase? Do you think it's going to go a lot bigger than what it is now? It's certainly going to go more granular, which is what you're talking about here.
Right. So I think it's just the beginning of it, and still a lot to go, and that drive a lot of new design activity, and because some of that, we're kind of moving into what I call it the domain-specific processing. And there's a lot of new method, AI, machine learning, quantum computing. There's a lot of new way to change the paradigm of the computing. They're going to drive a lot of innovation, and depend on what application you try to drive. So it's exciting time, and this is innovation. If you love innovation and then changing the world, this is the best time.
There's a lot of buzz certainly around AI and machine learning, deep learning. People are developing AI chips and machine learning chips that are specific for specific reasons. We seem to be almost at the beginning of an explosion of this market where we have way too many companies, and they can't all last. I mean, sooner or later, something has to come out where there's a rationalization of this market. How do you see this unfolding?
Yeah, I think AI machine learning is very broadly impacting the industry. So in fact, if you look at very different vertical, if you add it up, the impact will be about 43 trillion. So it's huge. And so from all the way to radiologists, the data, in fact, I just invest one in this area, and then all the way to, now I call it the power efficient processor. In fact, I can show you a chart. The general purpose CPU is climbing down the next couple of years, and it replaced by the GPU, FPGA, and ASIC. And so it basically, the workload have changed. Compute is not everything. And so this is a paradigm shift is tremendous. And so some of the vertical, from the supply chain and the software as service, all the way to medical, genomic sequencing, it's all about data. And then automotive is just one of them, and it's very hot right now. And so I think overall, I think the impact is quite significant. Like any new paradigm shift, you're going to have a lot of startup coming up. They all have different version of power efficiency they try to drive, and that's for specific applications. And then over time, the 100 or 200 startup, it maybe end up to 3 that are world-class company. And so some of them got acquired by the big guy. And so I think this is a very exciting time.
This is almost like when we started to see the rise of Amazon and Google and Facebook going back in the early 2000s, right? Late 1990s. We could see another company of that size that we never saw before. Even Apple came out of almost nowhere in 2001 with the iPod.
Possible. So it depends on what vertical, and is a sea change, and whoever embrace the change, and they will be the one that survive and excel.
One of the staples of this world, because it's changing so fast, and we're seeing this certainly in the training algorithms as well as the inferencing, is everything's changing all the time. As a result, you have to build flexibility into this. You can't necessarily build the ASICs that you used to build for a smartphone and say this will be good for 1 billion units for this long a period of time. Sometimes this stuff changes in a week, sometimes even a day. What happens in terms of the design of these chips, in terms of the design of the architectures to make this work?
Yeah, so I think this is where the excitement come in. And so, like for example, in Cadence, first of all, we have an inside and outside approach. The inside, basically, we use a machine learning, deep learning, applying into our tool to drive the productivity and efficiency. And then also, I think you saw our announcement on the cloud, massively scaling, and so that really benefit customer, so that their runtime and PPA is much faster to get the result, so that they can shorten their design cycle and also the verification, so that they can really come on the market much faster. And then the other part is, we really try to optimize some of our tool for some specific application. And we're talking about the machine learning, deep learning in the processor side. And so at the heart of it, basically, is you have that algorithm compiler. Really have to drive the mapping down and the scaling acceleration quickly, and so that we help our customer to do that. And then the other part is some of the silicon that you want to optimize. And the GPU is great for some function, but the power is really high, power hungry. Right. And then so how do you optimize the processor design to make it really power efficient and optimize some of the per function are redundant, and you can kind of skip that. And so they make it optimized, either it's a training or inference. And that's something that's exciting. And then, and depend on what application, if it's for industrial IoT, and then it's more important is kind of, I call it the neuromorphic, a little bit like brain. You wake up, you process, and then you send something, and then you go back to sleep. And you wake up again, but you can turn on quickly, and that's the key, and without the latency. And so I think those are the things that is fascinating, and depend on what application you try to drive. And there's many startups are doing that, and some of the big guys also doing it, and it's fascinating.
You must wake up much better than I do in the morning.
I have a big switch, so I switch very fast.
This does require, though, a much faster time to market, and also an emphasis on reducing the cost, because you do have to change these things out much more frequently. This has been one of the things that Cadence has talked about in the past, where you're trying to get to what is the equivalent of mass customization, because each one of these is different and they change all the time. How do you do that?
Yeah, I think clearly when you move down the geometry, we are all good engineers, so people kind of worry after 7 will you still have life? Still a lot. You have 5 nanometer. We are already working with customer, and we're already working on 3 test chip already, and so we are moving down the geometry. And of course, the question mark is whether the cost and whether you can afford it. And then the other part is how to do clever, smart design so that you can have first time pass. And also the other part is, how do you drive the power down and the cost down? And we try to do everything we can to, our job is basically helping our customer to design the most sophisticated silicon. And now it's become more and more complex. And not just the digital side, you also the analog mixed signal, and a lot more complex in the much smaller geometry. And even beside the design, and also how do you do the packaging, and then the overall system, the overall envelope, and the power and signal integrity need to build it in. And that's why it's very important to kind of look at the totality, and we call it the system design enablement. And so that you really have to look at the entire system point of view and then work backward, and so that you can see how we can help the customer to drive that cost reductions. And also, and when you go down that geometry, it's very complex. And that's why sometimes it's very important to work very closely with our customer, with our foundry partner, our IP partner, so that makes sure that every pieces are gel together and then really drive the optimized solutions.
Cadence was one of the early proponents of system in package and advanced packaging. As a matter of fact, I think you were overly optimistic about how fast the market would take off because it just seems to be finally getting going. Do you see that as a strategy for building almost platforms and interchangeable pieces as time goes on?
Absolutely. And that's why I mentioned earlier, you need to have a look at the whole system point of view. And beside the silicon development, you want to see the power envelope and the packaging, 2.5D, 3D, and then also the whole board requirement. And so that's why we have Allegro, and also we have the security that kind of do the power signal integrity analysis. And then right now we move even further, and some of them were internally developed, some of them we work out with partner like MathWorks, and then so that we can really do from the system modeling to system simulation and all the way to the silicon, and so that we can provide a total solution to our customer.
We've talked a lot in the past about automotive, and that's certainly one of the hot markets these days. As we move down into more autonomous vehicles, or at least assisted driving, which seems to be at least the immediate path forward, when we finally get to level 4 or 5, I have absolutely no idea, and I'm not sure anybody else does either. But do you see the power starting to change? Not so much the power of the physical power, but the industry power in terms of who's going to be running this? Is it going to be Apple and Google, or is it going to be the car makers?
Well, I think this is a hot topic for me. Hold on a second, somehow it dropped here. And so I drive my Tesla car, and I don't feel like a car. It's almost like my computer, and but just a 4-wheel, and all my calendar, everything, all my music I like from my phone extended to the car. And then some of my colleagues worry, from my home to drive to office about 1 hour, at least 50 email and texts. So, and ideally, I can't wait to get the level 4 and 5 in place. But clearly it's a race. Everybody is trying to do, and from the big guy, from tier 1 to ODM, and then some of the people coming in from the IT side and try to drive the car. But I think we're still a long way to go. I mean, we can do the level 2 assisted, and the security is issue. If somebody hack into your car, how are you going to address that? And it will be a massive accident happening. And then the other part is all the sensor, from radar, and camera, and all these sensors had to collect the data. And also, you need to have a superpower computer. If you open the trunk, there's a big computer at the back, and somehow to bring it smaller and then more cost effective. And I'm sure you will get there. A lot of people are working on it. And then some of them is, like General Motors is really aggressive, and a friend of mine is doing that. And then, cruise automation are now with SoftBank behind it. And so they make a lot of progress. And then of course, the Waymo and a few others, if you test drive some of them, they are pretty good. And but can it sit at the back for the car to drive? I'm still not quite there yet. And then, of course, the insurance, the regulation you have to take care of. So I think all in all, I think at least in our lifetime, we will see that.
It's going to, everything is up for grabs though, right? I mean, there's nobody that is assured of a place in this. It's now, you may be a leader today, but you may not be tomorrow, or you might be a bit player today and you might be a much bigger player tomorrow.
Yes, that's pretty much like any industry. And that's why exciting about innovation and also the business model change. And so used to be that number one in the industry overnight can be disappeared and somebody else take over. Look at Netflix, you look at the Amazon, and so a lot of store will be disappeared. And I still miss that. Sometimes I still like to see the video store and pick your movie, but now it's everything on the web now, so online. So, it's a good and bad.
One of the issues involving autonomous vehicles is the electrification of a car.
Yes.
There's been a lot of proposals in terms of, we're just going to turn everything electric. That doesn't seem to be a rational approach to the world, because you can't just run a 440-volt line into a gas station that exists today. How do we get there? Is it necessarily purely electric, or is there going to be a mix of, how do you see this market unfolding? Will it be a mix of fuels? Will it be just one or the other?
Yeah, hard to predict. I mean, I think you're going to have both, and if it's a short distance with a lot of chargers station available, like in Bay Area, and then the quick charge and the super charge, and then in Bay Area, Tesla is very effective, but in some other places, it's not have so many available charging stations, and so that can be a challenge. So it depends. So I have the hybrid car, and then a diesel car, so that if you have to go long distance and you calculate the mile, the round trip, and then in case you don't have a charging station, can you get by? If you can't, you take the other car. So, and I think if they continue to improve, now it's 287 miles, hopefully 350 miles, hopefully extend enough that you can make a round trip back.
And to drive this and to make it autonomous, you're going to need some very sophisticated electronics. You had talked about basically what comes down to a supercomputer in a car. Most supercomputers today are very expensive. Even small PC-type supercomputers are probably more than most car companies are willing to pay for a computer. Can we shrink that much capability down at that level? Is this consistent with the kind of gains that we've seen in the past?
I'm confident we will get there. Just like, in your pocket, you have a supercomputer 20 years ago in your cell phone. And so I look at most of the startup company, they come to me for funding. And so in a way, I pretty much see some of this disruptive technology that are building. I'm excited. I mean, they making tremendous progress in terms of the very cost-effective way, the power efficient way to design. And so I think they're going to get there.
You had mentioned the industrial IoT. That seems to be a market that's really taken off. And at one point, everybody was thinking, it's Industry 4.0 or smart manufacturing. The reality is a lot of companies have adopted this. What has that done from the design standpoint? Because a lot of these are one-off type of applications.
Yeah, not quite actually. And the Industrial 4.0 is happening right now. So, I'm on the board of HP Enterprise. I mean, we have this Aruba. This is a campus Wi-Fi and the switches. And right now we are proliferating a lot into some of the vertical industry so that you can collect data, you can process in a very cost-effective way, and also you can transmit in a very quick way. And recently, I just came back from Israel. I make a personal investment in one of them that able to capture the energy from the ambience, and then you can send for IoT data, and it's already working. I was so impressed. The team is really very bright. Just a few days ago, I saw the demo in Israel. And so I think able to collect the data, able to transmit the data in the near threshold voltage in the 0.25 volt and below, that is hard to do, but it's already people able to crack that. and so that you can use a lot of thousands of neural, and then with a very low power, just like the brain, and there's a lot of neural, and then you wake up and you process, and you go to sleep, and you can recognize, this is Ed, and in nanosecond, and when you wake up, and you don't have to wait and process. So it's getting there. So I'm excited about it, and then the other part is a lot is software. And if you look at the machine learning, deep learning, the heart of it is a compiler and algorithm. And then whoever have the best, the software, and that's why Google is very aggressive on that, and that's playing to their strength.
How do you see EDA fitting into that? Will we be able to take some of the tooling and the knowledge that we have and apply it into machine learning?
Yeah, absolutely. And in fact, at Cadence, we have a big effort into crossing all our product tool using machine learning, deep learning on the inference side to help our customer to make it faster, converging. And so we already see the earlier promising result, and customer love it. So they are working with us, and the best way to really implement it is work with our tier 1 customer, the leading customer. They embrace it, and they work with us, and then we see, we can show them how quickly, the runtime, the PPA can perform for their own applications. So we are still in the early second inning, and so a lot more to go. And I think going to be helping a lot of our customer to drive the productivity faster. And then not only the machine learning, deep learning, and down the road quantum computing, and then with the cloud partner we have, and we can massively helping our customer to design much more better product that we all can benefit.
But will your tools that you have today or future tools be able to actually improve the algorithms themselves and debug them and help design the chips themselves that will run this faster?
Yes.
So that's on the drawing board too.
Yes. So we have effort, and it's not a 1 year, 2 year, it's a continual effort. I mean, this is thing that we already see some good result, and then we're just applying to different tool. And first of all, start with the place and route, and then now we're starting to apply into our verifications, and then and moving to our analog, custom, virtuoso. So I think tool by tool, we are working on it, and also try to bring some of our verification suite, the implementation full flow. How do we drive even further result for our customer? And at the end of the day, we are serving our customer. So, we want to make sure that they can drive the productivity and get the most complex chip come out first, so that they win, they can buy more of our tools.
You mentioned quantum computing in passing here. I'm wondering, are you actually getting involved in this at this point? Is this something that's on the roadmap for the future, or is it actually under development now?
Yeah, it's interesting. I mean, I have been reading and then study and visiting company, and of course they reside in some of the big company, and couple of startup company also coming up. I think at the end of the day is what application can drive the business model. And it's fascinating, but I think technology and how to scale it, and more repeatable, and to apply into some specific vertical. And right now I'm anxious to put into work into 2 or 3 vertical that I can see the benefit.
One of the great gee whiz markets of recent times that keeps showing up on the drawing board, and we never quite seem to get there, is medical IoT. Mm-hmm. Where are we? Are we actually making progress here, or are we still held back by regulations and all the field tests and everything else?
Well, we are making progress. I mean, clearly, we all wear some kind of device, and then my device actually is kind of Fitbit. And is it accurate? No. But it's kind of useful for me to communicate with my son, and then also keep how many steps. If I'm not getting to my 10,000 or 15,000 steps, I have to do some work before I go to sleep. And in some ways, good. And that's for communication. And then, in fact, I think there's someone mentioned that I'm not trying to make a commercial here. The iWatch, somebody have a very irregular heartbeat, is almost die, and it gave him the alert, and then go to hospital, and then save her life. And that, I thought, is a great improvement. But I think there's a lot more can be done. And so clearly in the genomic sequencing, and then some of the diagnostic earlier. And in fact, there's one company I'm involved actually give you an earlier indication of you have a tumor. And so that is fascinating.
How?
And so this company is particularly, just look at using machine learning and look at the radiologists and the data that you collect, and then able to identify the tumor earlier and more preventions. And then also there's another company I'm involved using the RF microwave. You can see behind the wall. And so I don't need to, I just a small size as my cell phone, I can see whether you carry a weapon or not. And so that is something that's fascinating to me. And that's a lot of good application, and that can be useful.
There's been a lot of concern about AI and privacy of data, things like that, the future of jobs. How do you see that unfolding? You certainly cover a broad swath of the industry in the world.
Yeah, I think there's something that our industry need to address is not just our silicon, and also right now is everything about data, and your medical data, your personal data, and then your household data, and then also if you are driving, there's a lot of data, and so some of them is B2C, like credit card, you get people stole your identity, that's dangerous.
Last week, yes.
Last week, right? And then, but even more concern is, some of your data being compromised on the business side. And for example, one of the hot topic I have with some of my foundry partner is, if you're going to put it in the cloud, how safe is that? How the security become a number one priority, because the design data, the customer data, you cannot be compromised, even worse than the consumer. And so those are the part that we work very closely with our, the hybrid cloud partners, and also our foundry partner and the IP partner, make sure that are really secure and to protect our customer data. So those are the things that it become more and more critical. The one that I'm more interested in the security part from Cadence is more the security that touch the silicon. And the application layer and above, and the service side, there's so many players, and also it's very hard to make money. And so it's more important to really touching the silicon and the embedded software related area that is more relevant to us and relevant to my customer, and that's something that I'm more focused on.
Has there been a lot of concern since the raising of Meltdown and Spectre, and as a possibility of actually compromising the hardware itself?
Yeah, that is a big issue, and your cell phone and some of the device you carry, the security level is very low. I had to tell you that. So those are the things. It's very easy to hack, and so that is a fundamental real issue when we have more and more data, and then how to protect that. And that is an industry issue that we need to address. And either at Cadence or somewhere else, we need to address that before we proliferate massively with all this data, and that's scary.
Well, it seems to be a problem at every level. You think about Equifax, which had one job, which was to protect your data, and they did not protect your data. So it's at every level. This is from the most secure down to the hardware and beyond.
Yes.
So we haven't gotten there. Can EDA tools help with this?
Yeah, so I think clearly from the Cadence point of view, security is very important to our customer, and so we put a lot of more effort in the verification side, and also some of the technique we can use to make sure that it's secure for our customer. And then meanwhile, when we embark on the cloud, and we have a very strong CIO and his team to make sure that our data is secure. Cybersecurity is critical, and a lot of hacking going on. And so we want to make sure that all this, either as our own hosted solution or in the hyperscale cloud, we want to make sure that we are really, really tight on the security. And then meanwhile, for our customer design, We want to make sure that they are verified and whatever the design and all the corner cases, the different environment we are in, we want nothing is 100% sure. And if I can be honest with you, but we try to do everything we can to protect our customer, and that's is a calling for us.
Let's go a bit more technical here. There's been a major struggle to move chips down, according to Moore's law, down to we're certainly at 7, we're moving to 5, we're moving eventually to 3, and then we don't know what we're going to call them after that, because if it's 1.5, we'll probably end up in angstroms. First of all, we've got a lot of technical challenges there. We've got potentially the need for high NA EUV. We've got all sorts of power issues and noise issues and margin issues. What does this mean in terms of, can we get these designs done in a reasonable amount of time for a reasonable amount of cost, and are there enough customers to be able to build those economies of scale that we've been able to do with a roadmap in the past?
Yeah, so I think that's a very good question, and so it really depends on what application. Some of this automotive or IoT, you no need to go down to that process node so advanced, and so that's a beauty part of our analog business, and that we can still use 19 nanometer, 65, 40, 28, doing perfectly fine. But even that, we are racing down to 5 nanometer, depending on some of the applications in our analog too. On the digital side, clearly we are marching down to 5. And in fact, if you ask me where are my most engineering are working on, is a 5 nanometer. 7 is pretty good shape and going to production. So I think either 7 or 7 plus, and we're talking about TSMC, and then Samsung Global Foundry have their different versions of that. And then when you move down to 5 nanometer and 3 nanometer, clearly you need EUV, and you need the double, triple, quadruple patterning. And in fact, we announced with IMEC on 3 nanometer has shipped. And so we have a lot of R&D development. We have to be always ahead of our customer, and then working with our foundry partner and IP partner. That's why my team is really busy right now in terms of so stretched, working with our customer to drive the leading edge process node. And so I think is workable. 5 nanometer, I think next year you should have some test chip working. And then we're going to move down to 3 or 1 plus. And so I think still a lot of room to go. And then on the other hand, we use a lot of technique. That's why parallelism is very important. Why machine learning, deep learning is very important. Certain point in time, maybe even adopting quantum computing. So I always have to think ahead of time what the industry need, and I make sure that my team are focused on the right R&D to support our customer in the future. And then meanwhile, we pick each industry, the first and number 1 or number 2, to work with us, because the best way is to work with the best customer. We know what they need, then we drive our tool to meet their requirement, then the rest will follow. And so I think it really depends. So there's a lot of technique and a lot of design, and that's why our R&D is the highest in the industry, because we are thinking about 5 years, 10 years ahead, and we need to be there for our customer.
Another piece of this is the IP that's going to be available at these advanced nodes, and the development process on the IP has become very, very burdensome and costly. How is the IP business at Cadence shaping up, and what's changed?
Yeah, IP is a good business, and last year we grew 18%. The demand is very high because outsourcing is become more and more. Because if you try to meet all the different protocol, is a nightmare. So most of the company, unless they really need to keep, some IP that are differentiating for them, the industry standard IP, they may as well just outsourcing out if it's a good quality silicon. So IP have a challenging calling for us, and it's not just another IP. You have to be really high quality IP because it affects the productions. And so if it's software EDA tool, if you have a bug, it's okay. You can work around it. And but if you have IP bugs, it hurt the production, it hurt the revenue. So we take a very special focus on the IP front. And then we pretty much have a good portfolio of IP. Now we are really focused on, I call it the star IP, like the Tensilica on the machine learning CNN engine is a very good one that we bought. And then recently we bought the new Semi, and that is a super ultra high speed SerDes. For the data center, for the switch guy, is a must have, and in the most advanced node. And so those are the one that I call it the mission critical IP. We're going to pick one by one, we're going to pick up some of this key IP. Over time, the customer just come to us, we have all the right IP for them, and then there are silicon proven high quality IP in the most advanced node. And then to be candid with you, right now my IP team are really focused on 7 and 5 and 3 nanometer. And so it's the most advanced node that our customer need from us. And we want to make sure that we are there for them.
Are you able to serve all the different foundries with the IP like you could in the past, or is it now narrowing to the point where now you have to make choices?
Yeah, we had to make some choices. Clearly, not all the foundry we can support. So we have to really, we're pretty much driven by the customer. The customer tell us which foundry they're going to use. And so we make sure that our IP are ported, optimized for the particular foundry. So yes, a lot of more work because the particular IP, you have to be ported to the TSMC, Samsung, Global Foundry. So some of the key foundry partners that we got to really optimize and being supported, and then so the customer can count on us. So that give us an extra burden of doing it. But again, customer request, and then we'll do it.
Are the big customers, and there are very few of them moving down to the most advanced nodes, are they still buying commercial IP at the same way that they did, or do they want almost combination of in-house versus external support, or do they just want to buy off the shelf like they did in the past? What's changed there?
Yeah, it depends on different customers. Some of them, they don't think that particular IP is differentiating for them, so they can just buy the industry standard. And then some of them, they want to have some small customization, and we're willing to do that for the special customer, and they're important to us. Either they are the leader in the industry or something they are very major breakthrough. And then the other part is, some of them, they just want to have some customizations. And so we also work with some of the top tier customer that we are doing some, we become their extended team to that customer so that they can count on us to do the particular IP that are only special to them. And we're willing to do that for some particular customers.
So putting all this in perspective and wrapping it up here, what is Cadence in the future and looking out several years? Is it still an EDA company, is it an IP company, or is it something else?
Good question. So I think we kind of articulate consistently we are moving into a system design enablement. And in fact, right now, we're putting a lot of effort into some of the vertical market. I strongly, from my experience, in order to grow the pie, you either go up or you go horizontal. So we're doing both. And so going up, that means that you're moving up into some of the vertical. So some of the vertical, you stay tuned in some of our announcement. Mil-aero, defense and aerospace is a very important focus for us, and we have some great success. Automotive, you mentioned earlier, is one of our big focus on vertical. And then the data center hyperscale guy are the very big vertical for us. And then just talk about data center cloud, is a sea change going on. And there's a lot of, each one of them are building some portion of their silicon team and also the system design team. And we work very intensively with them. We make sure that they can really differentiate in their providing the service and the scale out of the storage and network. And either it's an SSD or some, the intelligent switch that they want to build, and then the scale out of the data center. And then, or some of this, I call it the domain-specific processor that developing quietly. We want to be the EDA IP partner of choice for them to work with them because their CapEx is huge. And so they are the one that we're going to pay attention to it. Same thing with automotive, either tier 1 ODM or some of this, the fully integrated automotive car manufacturers. And we want to make sure that our IP and our tool are really be the partner of choice for them. So those are the things that we are planting the seed. We're in the second and third inning. There's a lot of more room to grow. So in a way, I think you're going to see that Cadence over time. First of all, we're going to triple down on our EDA. We want to be the best of class in every tool. And then secondly is the IP, the security, and then the packaging, the board, and the subsystem, and then the system modeling to simulation all the way to the silicon to the component. So this is kind of where we are growing from horizontal and vertical, but without compromising the quality and the leadership in technology.
So summing this all up, things are getting so complex that you can't put a quick label on anything anymore, right?
Yes, yes, absolutely. And at the end of the day, is we serve our customer. So make sure that the customer can design the best product in the fastest time and first time pass. And every respin of the metal is costly in the advanced node, as you know. And some of them is 15 million plus and going to be increasing.
Going to be a lot higher.
A lot higher. And so I think that's where the differentiating the leading company and the losing company is whether you have a first time pass culture.
Always an interesting conversation. Thank you.
Thank you.